We are then busy with mensuration. We're just looking at a circle again. This is the 3 formulas that you need to know of a circle. You can write this now in your workbooks. Circumference, 2 pi r, area, pi r squared, and then volume, pi r squared h. So please write this in your workbook. And then we're going to look at a circle a little bit. Right, there's a nice perfect circle. And let's just look at what we should know about a circle. So this is the diameter. You know that this is the radius. This is not new. You know these parts. Now, what we should also look is this, which we call a chord. A chord. That is then the chord that you have there. Obviously, this part is the circumference. Circumference. And what we're going to look at now is this length. Part of the circumference, can you see that blue part is what we call the arc. That's the arc length. And this is what we're going to learn now today, how to calculate that arc length there. Then this part is called a sector. It's part of the area. Sector, it's like the piece of pizza or the piece of cake that you are eating. That is the sector that we're going to eat. And we are going to learn now how to calculate arc length and sector area. That's the purpose of our lesson today. That's what we want to do, to find those lengths there. Now, we know that circumference is 2 pi r. And you know that area is pi r squared. This is what we already know. And this is what we're going to use now to calculate that arc length and that area length then there. Okay? And the last thing that you can write down there is now arc length. Yes, just now. Arc length. Okay, there's the previous one. There, the circle. Is that what you want? Okay. So as I say, now we're looking at the arc length and the sector area. That's what we want to calculate now. It's not difficult. It's just 2 little formulas that we need to know, and then from there we can work. Okay, can I go on? Okay, so the arc length, what we do, so you have this part looking like this. And what we want to calculate is that arc length. That's what we're looking at now. That's the arc. Now, this is called the angle theta. It's still the angle. And we work with that. We use that angle to calculate it. So the formula is theta. How many degrees do we have in a revolution? Right around here? 360. 360, that's right. So theta over 360 of the circumference, because the arc length is part of the circumference, so of 2 pi r. And that's your formula there for that arc length. Theta over 360 of 2 pi r. Right, and then the sector area. The sector area, as we said, this is now the piece of cake that you want to eat, or the piece of pizza or whatever. This is the sector area that we're talking about. This is part of what? No, of the area. It's part of the whole pizza. It's part of that there. So this one is theta over 360. So theta is then the angle that we have there of the area, so of pi r squared. That's the 2 formulas that we're going to use. Okay. So your brain likes a block, so put it in a block there so that you can see them. That's what we're going to use. Okay, so in the textbook now, Okay, so in the textbook, this is on page 505. Page 505. So page 505. And you can see, look there on page 505, there they are also explaining all the parts then of the circle that we also looked at. You will see that they also have a minor and a major sector or a segment that you have there. And we're starting then on page 507 with try now 14. So page 507, try now 14. Try now 14, that's where we're going to look. Okay, so I'm going to explain the first few and then we're going to start doing them. So try now 14. Right, so let's look at the first one. Find the length of the arc CPD in each of the following diagrams if the radius is 10. So the radius is constant now here. It's 10 all the time. Right, so what is theta in this case? What is your angle here? Page 507. Yes, very good. It's 90 degrees. So my formula is now theta over 360 of 2 pi r. And if you really want to learn formulas, the best way is to, while we do them, write them down every time before you substitute them, rewrite them, and that's how you're going to learn them and remember them. So in this case, it's then 90 degrees out of the 360. It's always out of 360. And what is the radius? The radius is 10. Okay? We can simplify this now to a quarter, but you can also just multiply it. So we're going to say a quarter, or you can say 90 over 360 times 2 times pi times 10. Just look here, you may use for pi, you may use 3.142. That's what they say on the front page of your paper. Or you can use second function. The pi one is usually there at the bottom of your calculator. Okay, so 90 divided by 360, and then times 2 times shift pi times 10, and what is the answer that you have? 15.7. Okay, now let's just learn two things here also. The one is, you must always first write down the unrounded value. For geometry, we first write down that unrounded value because you're going to use it in part B or C. And then we round off and we indicate the rounded off one like that. And in this case, it's 15.7. Your papers also say 3 significant figures unless otherwise stated. So all the time we're going to round off to 3 significant figures. Or they say 3.142. I think in grade 9 or so they learned you to use 3.14. But now we have to use 3.142. Okay, for that one. Make sure that you know how your calculator works. That's also very important now here. Right, that was now the first one. I'm going to do another one for you, and then you can try. Number B, what is theta in this case? So we start with a formula, theta over 360 times 2 pi r. What is theta in this case? Yes, 180, so it makes it very easy. It's a half out of 360 times 2 pi r. So actually, that will cancel out. What? So what is the answer that we get?
31.4159.
Yeah. It will give us 31.4159, and we round off to 31.4. 3 significant figures. 3 significant figures. Right, I want you now to try number C and D. Let's try number C and D, using the formula all the time. There's the formula. There's the formula. Theta over 360 times 2 pi r. And in this case, the radius remains 10 all the time. Yes? Do you have a question? Okay, what? I'm coming 24.43. Okay, and then we round off to 24.4. Don't be lazy with this, because otherwise you have to redo it again. You must use unrounded information in a B part or so. Okay, number D. Number D. Now look at number D. There we want the big arc, so we're using 300 degrees over 360 of 2 pi r. And what does that give us? 52.36, and this one will round off to, isn't it? 52.4? Three significant figures, 52.4. And obviously this is actually centimeters, because it's arc length. It's centimeters all the time, centimeters. Right, let's look at number 2. It's a little bit different that they ask it. The minute hand of a clock is 10 centimeters long, so we still have a circle. And then they say the minute hand moves 5, so it's 10 centimeters, but it moves in 5 minutes. So how far does it move in 5 minutes? So there we have to calculate the 5 minutes, out of 60, because you'll have to, we need to find that angle. Can you see? That's what we want, that angle. It's then the 5 minutes out of 60 minutes. So it's then 30 out of 360 of 2 pi 10. The radius is still 10. And then what is this one's arc? 5.2359, which is 5.24. It rounds off to 5.24 centimeters. Okay, so that's now the basic thing. Everything is with this one formula today. So now we go over to try now 15. Copy and complete the following table for the arcs of the circle. So again, I'm going to show you the first one. Try now 15. So we have the sector angle, you have the arc length, but you don't have the radius. Can you see? So it will still be the formula of theta over 360 of 2 pi r. We're still going to use that one. So if I substitute now here, the angle is 120 degrees over 360 of 2 pi r. R is what I need to find, and what I have is the answer. I have the arc length, and the arc length is 25. Can you see? The arc length is 25. So it's now just a little calculation there to find it, and it's all about opposite operations here. So I want R, which means I'm going to multiply by 360, because here you are dividing by 360. Can you see? Here we are multiplying, so now we are dividing by 120 times 2 pi r. So it's about opposite operations to get that length then there out. Okay, let's do that calculation. 250 times 360 divide by 120 times 2 times shift pi is equal to 47. No, so the radius 11.9. Yeah, that's what I get. 11.9. 36. No, it's still 11.9. 3 significant figures will still be 11.9, and it's still centimeters because you want to calculate the radius. You want to calculate the radius. Okay. So we're marking now number B, 1B, and again you have to find the radius. So I'm going to say that 230 over 360 of 2 pi r, that's what we need to find, is equal to 6. They give me that arc length. So opposite operations, this is what we're doing here, 6 times 360, and you divide by 230 times 2 pi. And what is your radius length? 49. Is it rounded now? Right, question 2. In the diagram, O is the center of the circle, the reflex angle 315, and the major arc, major is that long arc, the big arc is the major arc, is 24. Find the radius of the circle. So we're going to do it in exactly the same way, that 315 over 360 of 2 pi r. You still need to find that one, and they tell you that arc length is 24. So opposite operations, Rain, what do you have here? What is your radius? 4.37. It rounds off to 4.37. But it is important, what was the one that you got before you rounded? 365. Okay, but still, we want it because we're going to use it in the next one now. So it's 3.7 when you round off. Now they say it be the length of the minor arc SR. Now, what we actually need there is that angle, isn't it? And what is the angle 360 minus 315? Jaco, what will be that angle there? 45 degrees. So 45 out of 360 of, what do we need to find? The length of the arc, so times 2 pi. And now I use this radius here of 4.365, the unrounded one. That's what you're going to use, that unrounded radius. Okay, and what? Yeah, so the final answer is 3.43. So this is nice ways how they can also ask it, and not just straightforward finding that arc length or finding eventually the sector area. So number 3, a piece of rope is 90 centimeters long. So that is that DC. It is formed into a sector OC, the ED of a circle, and the arc subtends an angle of 119. Find the radius. So the same thing here. Write down your formula, theta over 360 of 2 pi r. This is what we're dealing with all the time. So it's 110 over 360 of 2 pi r we need to find, and it is equal to 90. Opposite operations, what is your r then? Okay, so if you press the calculator, we get 46.9. 46.9.
Nothing is too good for my daughter. Now here's the deal, Nambi. There's no playing around with other boys before your wedding. Do you understand me? It's the most important day of your life.
Nambi, baby, you have a face like a beautiful person. I got you this Virgin Mary necklace to protect your innocence.
Stupid man. We have loved each other since high school, and now you want to turn your back on me? All the plans we made, you just throw them away? And you want Nambi now? When I've always been there for you, Ziwa, do you understand? And she doesn't even love you. I wasted my time on someone like you.
Don't be like that, Jalia.
Love, everybody needs it. Love.
We looked at the arc length, the length of the arc. The arc is part of the circumference, grade 11's, circumference, and the formula was then theta out of 360 of 2 pi r. That gives us the arc length. So you had homework, and that was then try now 16. So we're starting with try now 16 on page 509. Page 509. Right. In the first place, you have that table. Copy and complete the following table for arcs of circles. So this time you had to find the angle, but we are using that same formula. So the first one will then be theta over 360. This is what you want to find, times 2 pi, the radius is 3, and that arc length is 10. The arc length is 10. So it's also opposite operations, as we said in the previous lesson. So I can say that theta is equal to, here I divide by 360, so you're going to times by 360. Here you times, so then we are going to divide. And we also looked at the use of pi on our calculators. It's the answer then of that angle. The difference comes in by using pi or 3.142. No, angles, it's a good question. Angles is always to 1 decimal place. Remember with trigonometry, we also had it. Angles to 1 decimal place. It says on the front page that. I think let's agree to all use pi. It's actually easier, and because then we get the same answers. So this one is 191. Okay, so now we do A. And A will then work the same way. Theta is equal to, so your arc length is 40. You times it with 360, and you divide by 2 pi, and this time the radius is 20. So now it is 114.6, or if you have 150 now, it's right, but angles to 1 decimal place. This is with trigonometry and geometry, the two rules that we really have to look at now there. Right, now we come to number 2A. The radius of the sector is 14. For each arc length, calculate the angle. So, but look at the rounding here to the nearest degree. Can you see? So now it is different here. So I'm then going to say, using my same formula, theta is equal to, so this is the formula, let's just get it again, times 2 pi r. So theta is equal to the arc length is 12 times 360, and what was, Pesci, what was your radius? 14. Now the radius is 14 all the time. The radius is 14. Okay, yeah, the answer is 49. You're right. Did you have that correct? Okay, so that's why we do that. Right, number B. Janu, what is your answer for number B? 80. Theta is 80 degrees. That's right. Number C, we're using exactly that same method every time. Ruan, 263. Did you do that exercise? Yeah. So theta is 346 degrees. So it is still using that method every time. It's the arc length times 360 divided by 2 pi the radius. That every time it will be divided by 14 because the radius is 14 all the time, isn't it? Okay, now we're looking at question 3. The diagram shows the minus sector OAB of circle. OA is 10, that's the radius, or OB, sorry, is the radius is 10, and the arc length is 21. Find OAB. So it's the same thing, theta over 360, Ashley, of 2 pi, what is the radius? 10, and what is the arc length? 21. So I'm using that same formula. So then we're going to say theta is 21 times 360, divide by 2 pi r, and then what do you get? OAB, 120.3. This time they didn't say to the nearest degree, so we're back to 1 decimal place. Yes. Yeah, let's just look at that one. Now you have to find the arc length of, the length of the chord AB. Now, yeah, let me just draw that picture there. Okay, what is the chord AB? It's a straight line, Jan Ivan, isn't it? So now I'm going back to trigonometry now here to be able to do this one. So this one is 10, meaning this one will also be 10, isn't it? And you found the angle now to be 120.3. So now you have to calculate AB. Okay, Jan Ivan. So what did you use? To get that straight line, the third side, you have to use the cosine rule. Okay, I'm listening to yours. Tell me. Yes, I'll do it here. Okay, so I use the cosine rule here. So I said AB squared. And people, this is what it is. Trigonometry and geometry are often mixed. So it's then 2 times 10 times 10 cosine 120.3 degrees. This is the formula that we will be using. Trigonometry that we've done now. And then remember to write AB. It's not AB squared anymore. And it is then that 17.3 with trigonometry. So all the time we are busy with trigonometry as well. And then the last question, am I too quick, Jan Armand? And then the last question, question 3, the diagram shows the minus sector. So again, we've got that shape with a straight line there. This is the sector, this part, the piece of pizza or cake that you're eating. Find POQ. POQ. So how will we find this angle here? This is POQ. Depending on the information that we have, this time this one is 20 and this one is 10. So actually, if I just look there, it is trigonometry, a triangle that I'm using here. It's not the geometry part at this stage. So obviously this one is also, no, this one is 15 and this one will also be 15. So what do I have? Basically 3 sides. So I want to find that angle, isn't it? So cosine O, for those of you who struggle with trigonometry, this is the angle that you want. So this is the one that you're going to subtract. So it will be 15 squared plus 15 squared minus 20 squared over 2 times 15 times 15. It's the cosine rule with the angle. Second function cosine. What is the angle, Jan Indrek? 83.6 degrees. 83.6 degrees. 4A. Okay, and this is the angle that we are calculating now there. So once we've got this one, we can now, the next question is now to find that arc. So the length of the arc, so now it is theta over 360, which is then 83. This is now B. 83.6 over 360 times 2 pi. And what is the radius in this case? Yeah, not the 20, but the 15. I'll multiply there by 15. And Maxine, what did you get for Anna? 21.9. Good, Anna. 21.9 centimeters. Remember, this is arc length, so this is centimeters. Okay, grade 11s. Now today, the new thing that we want to learn is the sector area. So this is now the sector area. And as this is new work in your grade 11 syllabus, these questions are always in those papers. So, No, this is not new in the syllabus. So sector is a part of a circle. It's that piece of cake that you are eating. So obviously the formula is going to be part of the area. So it's theta over 360 of pi r squared. That's the formula that we are using now. Write it big, perhaps there in your book so that you can see it. As I say, write it down every time. That's the quickest way to learn these things here. So in our textbooks, on page 510 and 511, they have long explanations about this. But we're then going to be now on page 512. Try now 17. Try now Try now 17, page 512. I'm explaining the first ones. Try now 17, number 1. I think you will find it easy, as we've already now done the others there. Find the area, the shaded area. That's what we want to find there. So, Jaco, what is the angle then that we have on number A? So 90 out of 360, theta over 360 of the, and the radius is 10. So, very easy, that one. We press our calculators, and this one is 78.5. But this time it is square centimeters. Square centimeters. Okay? Square centimeters. Perhaps for some of you who make mistakes, first square, and then you multiply backwards. First square, then times shift pi, times a quarter. Okay? Right. What is the angle at number B? No, 180 over 360, okay, of pi 10 squared. You're a little bit too quick. What is the answer? 157. So that sector area that you're going to eat is 157 square centimeters. That's your sector area. Ben, number C. What angle do I have now? Okay, 140 over 360 of pi r squared. It's all the time the 10 squared that we have there. And Ben, what do you say is this one's area? 122. We round off to 3 significant figures. So that's that one. And then the last one, number D. Marley, we're back there with you. What is the angle this time? Yes, because they want the shaded area, not the 60. We want the shaded area. So it will be 300 over 360 of pi r squared, 261.8. Do you all, 261, 262? 3 significant figures. Do you all get these answers with your calculators, or do I need to come and help somebody? Okay, I'll come just now. Right, we're going to do number 2. And then you're going to try a few on your own. In the given figure, O is the center of the circle, radius 9 centimeters, RO is 150. Find the length of the major arc. So the major arc is the big one. Again, what is the angle this time? Yes, not. Be careful there. The angle is 210 because you want the shaded area times 2 pi r. Oh, yeah, I am right, actually. Sorry. I am right. So it's 2 pi r because I want the arc length. So it's mixed now here. And this is again centimeters because it's arc length. So now you can see how they mix it also. At the B part, now we want that area. Now we want the area. So now it is of pi 9 squared. Yes. But did you do it, or did you get the answer somewhere? Okay, that's also nice. Sometimes you must be cruel to be kind. Okay, now I want you to do, try now 18. Okay, come. So try now 18. Nice mix exercises that we have here. Copy and complete the table. So we're working with our formula, theta over 360 of pi r squared. This is what you're dealing with here. So you must find the angle. So it is then theta over 360 of of pi 6 squared is equal to 25. I'm explaining the next step because there's still people who struggle here to what to do now here. So theta is equal to 25. Opposite operations. Here you divide, there you times. Here you times, so now you divide. Don't forget about 6 squared. Second function, Jan Ivan, what did you get for an angle there? 79.6 degrees. 0.6 degrees. Right, so number B works now very similar to this one. So we can say theta is equal to, Armand, the area of the sector is 5. You multiply by 360, divide by 2 pi, and the radius, no, why do I keep on doing that? Pi 2 squared. What is your answer? 143.2 degrees. Okay, now we're at question 2. In the figure, O is the center of the circles, radius 6, find the area of the sector. This is straight for, no, they tell you the area of the sector is that, find the angle. So it's what we did now here. Theta is equal to, what is that arc length? Now, what is the area? Is 35. You times with 360, and we divide by pi radius squared, which is 6 squared. So what is theta in this case? Janu, 1 decimal place, Janu, for angles. 1 decimal place. This is what we need to practice now here. And then number B, the area of the minor sector. So what we said here is you've got this shape. It's actually a triangle there and a straight line there. This is my shaded area. So what we can do is to take this big area, which they gave you as 35, and then you minus the triangle. And the triangle is any triangle, so it will be half BC sine A. You need to know that formula. Seems to me that some of you don't even know about it. So it is then 6 times 6. And what is the angle? This angle that we have here, 111.4 degrees. Yeah, sine, sorry. And then actually we should use the unrounded information also here. You must use that, otherwise your final answers will be wrong. So if we subtract it, this one gives you, yeah, 16.759 to be precise. Final answer is then 18.2, and that is square centimeters because it's area there. Right, try now 19. This is then the last one, and it's a nice mixed exercise. You will see there's a lot of trigonometry also involved here. If we look at the first one now there, try now 19. We have these two, can you see the two sectors there, a smaller one and a bigger one. And again, you must calculate that shaded area. Now the shaded area will always be the big one minus the small one. Let's read this one. It's a word sum. There's also algebra here. The diagram shows a paper fan. The shaded paper area is bounded by the lines AB and CD and the arcs AD and BC. And you have those lengths there. OA is 5, AB is X. So let's just look here. This one is 5 and this one is X because you'll need that now. Just give me a second to show you how to do this one. How will we get this area? It will be the big one minus the small one. Now, if this one is 5 and this one is X, what is the length of that whole one there? No, not 5X. 5 plus X, and that's what you'll have to use there, 5 plus X.
I like rhinos. I like them very much. Future here in this area is depending on the tourism. The future generation, they can see and they can benefit from their own resources. Animals like rhinos, elephants, the big five, you benefit from them and it must be respected. You are not feeding the rhinos, you are not giving them order, so it's a free business. I take two of my sons, which was little bit 5 years old. They were young guys. So they asked me questions. Why are we here? Why are we sleeping here? I told them this is our resources and this is our future.
My first memory of going with my dad is that I learned new things. As I grow up as a man, I see an opportunity in it. So I decided to look for a job pertaining to tourism. So that's when I was employed at Palamba. So I decided to go for tour guide studies because I grew up with the tourism industry, the wildlife, the rhinos and everything, to bring that experience to the tourists. You can see the hyena. The biggest changes, I was employed, getting paid, and also I can now support my family.
It's a cultural thing. It's coming a long way. Even if you go to area like Tweefontein, area was a lot of paintings. You will see rhino engravings on the rocks. That is an indication that the interaction between human, especially the local communities and wildlife, is dating back. That intimacy relationship is coming for a long time.
We are right here now at Palamba, and Palamba is one of the big lodges in the heart of the desert. And as you can see there is Jumbo standing behind me, which shows it's really a tourist area. We do have elephants, lions, but as you can see, the desert is the heart of the rhinos. This is the main breeding area of the rhinos, is what we found here in this desert.
It's the largest free roaming population of black rhinos that you find outside national parks in the world. It's a population that communities in the Northwest have taken responsibility themselves in managing this population with the structures that government has put in place, more specifically the establishment of conservancies.
These people, before independence, they took it upon themselves and decided that wildlife is our heritage, and through history we've been living with wildlife. And having wildlife in your area is like having a garden.
Because of all these animals, we've got the communities that benefit from all this wildlife. And it's like a triangle that fits into each other. And the communities looked after the wildlife doing their own thing, and the communities benefit.
So already there were this intergenerational relationship between mankind and wildlife, and that bond is what our people actually wanted to see continuing.
Very few countries have the wildlife that Namibia has. What is also important is the policies that Namibia has put in place, which also involves communities to be engaged in the management of the wildlife species and also to benefit from the wildlife resources.
Turn conservation into a rural economy, turn conservation into endless opportunities that would actually cater for those young people that have nothing else to do.
If it was not for rhino economy and tourism in this area, it was really difficult for young people to get or find a job.
We are conservation engineers. We make conservation work in an unfenced area, and through that, we want to turn the wildlife into the rural economy that will benefit the rural communities.
So we can see now wildlife is doing very well, the lodges are doing well, and the community is also benefiting. So it takes all three together.
Devastating hit over coronavirus fears. Airline industry is facing its biggest threat to travel since 9/11.
Since March, when COVID-19 hit Namibia, things actually become very difficult. In the first place, all the lodges closed down because of COVID-19. With us, say the Rhino Trust, we had some donors cutting on their funding. And then we had, in the same time, a poaching case of 2 rhinos that was poached. We had less boots on the ground, and poachers could actually see. Now it's our chance to go in and do something. So COVID-19 was tough on all of us. Ginger Morning, who is one of our trustees, actually came up with the idea of, why don't we ask you to go to buy some gold for us and make gold bars, and then we sell them for the rhino conservation.
I was fortunate enough to have a chance to have lunch with Clive Johnson, the CEO of B2 Gold in Vancouver, Canada. And I looked at Clive and I said, we've got rhinos, you've got gold, let's do something. Let's create a coin or a medallion or a bar using your resource to create a sustainable source of funding for rhino conservation for the future.
There was it. The gold was bought, the bars was made, and I think it was 31st of January that we launched the bars in Windhoek. And suddenly one morning I had an email from my office, from my finance person, saying, these people don't have salaries. So I said, oh, what now? So I picked up my phone and I phoned Mark Daw. I said, Mark, I've got this problem. He said, but we've got the fund already ready for you. You just have to apply, put the proposal in.
1,000 ounces of gold can make an enormous difference to the livelihoods of the communities that live up there. We are, in essence, providing income and providing a livelihood to the communities. In the absence of tourism, especially now with COVID-19, even prior to that, when we had such a bad drought, the communities became even more dependent on the natural economy.
The idea is to make this a fund that will last for the next 25, 30 years, or even longer. And a portion of that will be distributed immediately as needed. And in this case, the COVID-19 crisis necessitated us to distribute funds to pay salaries to help people in the field.
The proceeds of the sales from the gold bars will be going towards responsible NGOs. And we've identified Save the Rhino Trust as the key NGO. And IRDNC, one of the first organizations that was in the Northwest, integrated rural development and nature conservation, so that ultimately the funds go to the communities and various aspects of their war on poaching.
To be able to support those hardworking men and women that are always in the front line between the poachers and the rhinos.
If it was not for B2 Gold and the golden bars, I think by now we should have been in big trouble.
By extracting the gold, you reinvest it in other renewable resources.
The gold that's coming out from the ground is actually protecting the wildlife that's working on the ground, which is a very good symbol for the others.
I wish this was my bar. This is the 500 gram gold bar. So you'll see on this side you've got the Etindeka Mountains and you've got the mother rhino with the calf. And then on the reverse side we've got the serial number You've got the Rand Refinery stamp, which is very important. Anywhere in the world, people will recognize the stamp and they will know that this bar contains 99.99% gold.
It is gorgeous.
We wanted to make a biggest contribution. And at Ballowwood, we see that as a way of giving back to the community.
Okay, so there you'll see the 500 gram bar.
Very special.
Feel the weight. It's incredible.
This opportunity which presented itself is absolutely a once-in-a-lifetime opportunity.
We're privileged to have this.
This is just absolutely gorgeous, and I think this showcase really what the project is all about.
It's from 24 karat Namibian gold.
I'm looking at these rhinos is put there like Miss World photogenic, I would say.
There are only 1,000 of these gold bars, rhino gold bars, in circulation.
As far as I'm aware, it's the largest single donation of any corporate to the conservation of biodiversity anywhere in Africa.
Therefore, we so much appreciate and would want to continue as a government to work with B2 Gold.
And the fact that it's happening here in Namibia is something that we can all be extremely proud about and very grateful to B2 Gold.
Thanks to having this literal pot of gold through the funding for the Rhino Gold Bar, we're able to step in now and make sure that those trackers are supported, and so are their families and their communities.
We make sure that people sustain their jobs going forward, and who doesn't want gold?
And the B2 Gold Rhino Gold Bar has come in at a really critical time now, particularly with tourism being closed off and those forms of revenue not coming in.
To say we have the biggest rhino population or black rhino population in the world, let it be for the rest of our lives. And it's that heritage that we have. It's our resource that we can all look after and protect.
It's our heritage. And it's also good that other people like B2 Gold are also seeing it that way.
It's actually a very nice link between the investor that buys this gold bar, the rhino tracker in the northwest of Namibia, and the black rhinos. It's an intergenerational thing. The rhino trackers teach their children how to track rhinos, their children get taught, and so it flows down.
This is something that I want my children to have, and that we leave a little bit of a B2 Gold legacy. And if I can be part of that as part of my family, I'd be very proud.
It can also become an inheritance for the generations of my own clan. My children, my grandchildren.
If we can bring that passion over to future generations and to hand that over to my children, and I hope that that same passion for conservation gets migrated over to my kids.
And what we've done together is create a sustainable source of funding that should outlive all of us.
You know, I think as far as B2 Gold is concerned, we couldn't have chosen a better target in which to put our efforts as far as the environmental and conservation pillar is concerned. And I want to stress there that the money that's going towards environment and conservation is actually going towards the people.
Rhino is for all of us, whether you are in Canada, whether you are in Vancouver, whether you are in the US. If you really want to see conservation at play with rural communities, I therefore humbly request each and everyone to join us on our rhino tour and have a wonderful experience. This is what keeps rhinos on this planet.
I've done rhino trekking experience. It was just amazing walking in that landscape of the Kunene. And as we followed them, we could now find rhinos with the calf. We got the closest distance we could.
It's a warning sign.
And it was just amazing and lovely, something to experience that Namibia can offer. It's something that you have to do in your life.
me. Just believe in me.
We know the world is a crazy place right now, but don't panic. Take a breath. Slow down. Or better yet, stop completely. We'll still be here when everything settles down. In this time of uncertainty, look to nature. She has all the answers, you know. We're not only giving ourselves time to reset, we're giving nature time to restore, revive, restart. We're saving ourselves and we're saving the world. Stay home now so that we can welcome you to Namibia again soon. Yes, the world's a crazy place right now, but don't despair. Find the joy, cherish hope, breathe. Take a moment, take a few, and someday soon you'll once again be able to stare in wonder at this magnificent view. The world's a crazy place right now, but don't worry, we'll still be here. We'll see you again soon.
More than ever before, football fans demand unique insight and analysis. The Football Review is much more than a highlights show. Bold, provocative editorial that goes beyond conventional reporting, setting the agenda for football discussion. Champions League, Premier League, La Liga, Serie A, Bundesliga, Liga 1, and much more. Want genuine insight with hard-hitting editorial? Need compelling premium football content? The Football Review. Best, bar none.
Surprises. Win your share of 300,000 in instant cashback surprises. Buy any participating product and swipe to enter. Plus, get store country spread for a low $36.99. Be Well Extra Virgin Olive Oil and Canola Oil blend for just $48.99. And Sunlight Hand Washing Powder for a surprising $39.99. Only at OK. Owners you can count on.